Hello, good evening to you and welcome to another exciting edition of our 1% engineering series. Okay, so today I've actually automated the a dehydration system using the adsorption method actually, and for just a twin bed system. And then what happens here is that the wet gas, which is our feed gas, enters through this line. It could enter through this bed or going through this bed, and then it leaves from this bed or from this bed. Only one of these beds are actually in service, that is absorbing at the time, and while one is absorbing, the other one is actually regenerating, getting ready for absorption. Alright, this is an adsorption process. This is what you find in most LNG and gas plants facilities, facilities. So I've just demonstrated here how it works. This is in two phases actually. I'll just show from the DCS side how this switches, and then later if you're interested in that also, you can continue this video and then I'll show you how the program was actually done. One other thing you can use this program to do is that you could use it to actually teach your students or teach whoever you want to teach or train whoever you want to train. So this system, this program, DCS program, this for automating several oil and gas processes or any other processes available, or any other process available there in the market. So your audience can actually, or your students, your targets can actually know, visualize what you're talking about. Okay, so currently now it is telling you that V2 is cooling, right? So V2 is cooling, and that is why we have this valve open and this one open, which takes in the regen gas, right? So when the regen gas heats up your cools here, it exits from here and then goes out. Similarly to this one, similarly with this one. So here it's still saying cooling. I think I have 40 seconds for that. So after that it switches and then V1 starts heating. So while V1 is heating, it heats for, I think, for 50 seconds rather, and then after 50 seconds it goes to cooling, and then after cooling it just goes like that. So the status of this plant is currently in auto mode, right? It is actually in auto mode. I have not actually brought out the button for manual mode, but you can actually take this to the manual mode and then it's going to report manual here. So as you can see, while this is running, if I decide to say I want to stop this, I could choose the value of 0 for now, and then it tells me pause. Right, your heating has been paused. Now one of the reasons why you may decide to pause your sequence is you don't want to go to the back end of the program to actually extend the time. For example, if your bed was supposed to heat and achieve a particular temperature for after say 4 hours, and then after the 4 hours it couldn't achieve that temperature, even though this is not okay, you should make sure it achieves the temperature. You should monitor this properly and make sure it achieves the right condition, temperature. But assuming it didn't achieve that, so I can pause this and then allow this valve, it says V1 heating, allow these valves to remain open while the regen gas, the hot regen gas, flows right into it. So at the end of the day, you could see, since I paused this video, since I paused this sequence up to this time, you see that I've actually stayed for some time, right? But it's still telling me I am at 36.91 seconds. So, but if I allow this to play again, let's say I am done with the extra minutes or seconds I want to add, or hours, as it were, I want to add to this heating. If I go back to my, I want to play this, I go back to 1 and say play, it goes to running, and then it continues from the 37 seconds, and then after the heating time it actually switches to cooling. You'll see that it says V1 heating, and then it will switch to cooling, right? So V1 cooling, and then V2 has started counting for cooling, right? So, and it is actually running. The status here is in auto mode. If I show you this, although I've not brought that out, If I show you this, if I put this in manual mode, sorry, if I put this in manual mode, let's get this in the online mode. So if I get this in the manual mode and I put this in manual here, for example, since I've not brought that on the operator screen, you will see that the status has changed to manual, right? Okay, we may have to address this, but currently you see that the status is currently changed to manual. Probably I may want to remove this later or whatever. I think it's fine there with this status being here. But actually it is still running. Okay, your valves are still open, but your time has been reset to 0, right? The elapsed heating 0, of course it has finished heating, it's currently in cooling, but the cooling time, elapsed cooling time has been taken back to 0. So you could see that it's in manual mode, and then it is now left for you to actually manually select which of these beds you actually want to take to heating or cooling or any of these processes. All right, so let's take it back to the auto mode. Let's take it back to the auto mode, and you will see that it's in auto, and then your time starts counting again. Okay, so this is exactly how it works. For this is currently V2 is currently absorbing the gas and making sure you have a dry gas, and then V1 is undergoing regeneration, it's undergoing cooling, which is the regeneration process. All right, so one of the things I may do going forward, maybe in our subsequent lectures, is that I'm going to produce a sensor here, a temperature sensor, and then I will show you how this sensor increases as the heating timer also increases, right? If you're actually getting the hot gas temperature, if your regeneration gas temperature is actually being increased, right? So I will show you how that happens, how this temperature value, which I will put here in the subsequent videos, which I may put there. For now, I don't see the reason why I should go ahead and start doing that. But if you want that, then just drop me a message, and then I would go ahead and present that to you. All right, but let me show you how I made this program. This program, I made it with the Sequential Function Chart, right? SFC. Some of you may be aware of what the SFC is. With the SFC, Sequential Function Chart, I can actually model sequences, right? Processes that actually are in sequence, probably just like we have for the Molesieve heating, the generation. After the heating, we have the cooling, and then the valves have to switch over for the adsorption of the next bed to take place. Okay, there are several other processes that may require you to go through the sequential steps here, but let me just take you through what or how I achieved what I did here. All right, so for this one, I actually wanted to start with the this is the initial step. Whenever you're doing you could see how the program is really jumping from one step to the other step. So, but let's say if I take it back to the online, to the what is this mode again? To the edit mode. Now, if I take it back to the edit mode, you would see here that this is my initial step, right? I only made this program you're seeing here using steps and transitions, using step and transition. All right, so this is your initial step, right? This is your initial step. If you see, it has a double rectangle, another rectangle inside of it, unlike these other steps that do not have any other rectangle inside of it. What it means is that if I start this program, right, if I just finish writing this program and I start it, it's going to start from this block, and it's going to initialize everything I've actually said should happen in this block. So let's see what I have in this block. If I remember, this will just appear for you. You're not going to I didn't create it. You're not going to create it, so it just appears here for you. How did I actually come to this dehydration sequence? It's just like one of these your control modules. We're already familiar with this. If you have not seen my previous videos, you go back and see those videos so you know how I created some of this what the control modules are. So, but if I right click on this, my control module of Molesieve, and then I go to new, I can decide to go on, I would go on control module, and then my algorithm type, after giving it a name, which I called dehydration sequence here, don't mind the spell it. So the dehydration sequence, and then I want it to be written with sequential function chart, right? And then I just right click and open with Control Studio, right? Okay, and that lands me here. So talking about this initial step, if I click on this, you will see I have a step inside of it. Actually, how did I get this other test doc file inside of the test? So if I right click, I could decide to say add, right? Probably I want to add a step inside of, I want to write a code, some piece of code inside of this initial step. So but I've already written something there, and then if I double click and I go to expression assistant, you see what I've said here. I've actually said that if the heating timer, the input of the heating timer slash in slash cast in D, I'm forcing it to 1, not if now. I'm actually forcing it to 1, right? Now, what is the heating timer here? If you go to here, I created one called heating timer. So if I right click and I go to open with Control Studio, you will find that available there. So this is what I just read. If you see my dehydration sequence, it is actually heating timer, the input of the heating timer block, that is for this one. So this is the in, right? If I didn't rename this in, you would have been seeing DO there, but I have it as in, and then I'm reading the casting, right? Not like I'm reading the casting, I'm writing to the casting, because here I'm actually saying that the value should be forced to 1, right? So it has a value of 1 here, but I've actually used, very importantly, I've actually used the digital input module here. So I've actually used the discrete output, right? The discrete output module here for this particular one. Now, why did I do that? It is because I cannot write to an input, right? I can only write to an output. And I'm sending this program to do something for me at the input at this particular level, right? So if I'm going to write to this block, I want to write via an output, right? I can only make use of what I have here. All right, so I'm writing to this parameter cast in D, and then this parameter cast in D will transfer the value it has to out to D, and then it sends it to this retentive timer block. Now I've actually made use of the retentive timer here because it has properties which I want in my Molesieve sequence. Say for example, if I pause this, you discover that it stays paused. For example, I think I've shown that before. But if I decide to pause this again, you will see that it shows me pause and then it stays there. Now what I've just done here is that I've actually sent the value of 0, right, to this particular address. If I go back to here, I've actually sent the value of 0 to this particular address. So what is happening here is that if I show you this, let's see, I've actually sent the value of 0 here at this point. And if I operate it again and then go to 1 for restart, you will see that I'm actually sending the value of 1 to this so that the timer can continue. If you see, the timer is counting. So the retentive timer only counts whenever sorry about that. So the retentive timer only counts whenever the input signal at the in is true, right? And then it stops when it is false. But the beautiful thing about it is that it continues from that same where it stopped if the signal returns back to 1, right? So from 1 to 0 to 1, it continues from where it stopped, except you actually do a reset. So for this particular example, if I do, in the other time I showed you about changing this thing to manual, I'm actually using the reset. So I'm writing to the reset. You see how I was able to manipulate the timer here. So the retentive timer comes in very much handy and it suits my application. right? Currently, I'm resetting this because the timer, I think the heating time is done, right? So I have to reset it so that the elapsed time here will start reading the value of 0. Okay, let me just go ahead and take you through everything I've done here. The cooling timer again, just similarly to what I did here before, I'm sending it to 0, right? I don't want it to count at this first stage, because what I want to do is that I want to start by heating the system, right? So again, I'm saying cooling timer, I'm sending the reset value to 0, and I'm also sending this one to 0, because of course I want to make sure that these two timers for the heating and the cooling are both 0 on the input side, right? I do not want the elapsed time to be reset by any other thing which I may do in the future. So I just want to make sure that at this step I have the input values for to the reset to be 0. So what I've done here again is that I'm forcing XV22A, right? XV22A is the valve you have here. XV22A is the valve you have here. Actually, I was naming it 2A, but it's like I've used 2A before in my project. I can't find out what the problem is, but I actually had to name it 22, right? So 22A. So 22A here is actually this valve. So what happens is that I'm forcing this valve to be closed at this point, and then because I'm getting ready for heating, and then the B valve, which is the one at this point, I'm also forcing it closed for heating. Sorry. And then for your 2C and the 2D, which are your regeneration valves, I am forcing them open. Now, the next thing I did was to actually check here, right? To actually check here. This is your transition. So if you drop your transition, you'll see that you have exactly this symbol. Now, at the transition, the only time it leaves this step to this other step is if the condition at the transition is met. So if I double click on this transition, what have I done here? I've said you only move from this step to this step if the auto, that is, if it is in auto, right? This is the name I gave to it. But if it is in auto mode, and if the heating timer of that your retentive timer, the input, right? This should be equal to true, right? This one actually does nothing here now, but I think the whole idea was to make it, let me see this at the back. The whole idea here was to make it equal to 1. So if I made this equal to 1, sorry, not that, I can't be ended it there. All right, so I'm checking if this is auto and the retentive timer, right, on the input side, if it is 0, I think it should be 0, right? Sorry, it should be 0 because I've already forced it to be 0. Did I say 0? No, it was the reset. I said 0. So for this other one, I said 1, right? It has to be 1 on the input side so that the timer can actually start counting on the input. So if it is true and these valves, if this 2C valve is open and these other 2D valve, the regeneration valves, are both open, then I'm passing this. So that is the only time you are permitted to actually switch to this next step, right? So at the next step, other step, what have I done? If you go there, you see that the heating timer here, heating timer for the in, I've actually said it should be true, right? I think, did I did this before? Let's confirm. Let me confirm whether I did that before at this point. Let me check. Heating timer in casting D true. Yes, I did that here. So probably that may not have been a reason for doing that again here, but it's okay. It doesn't make the program misbehave. Probably I've just added more than I was supposed to add. All right, so the heating timer on the input side, on the in module, which is the DO, and then for the cast in D parameter, I am forcing it to be 1, right? So I expect the heating timer to start counting, right, at this point. And again, I'm forcing this cooling timer to be 0. So just more like a repetition of what I did before. And at this point, I'm making sure that the reset of the heating timer does not equal 1, that it equals 0. Now, at this point, why I'm doing this again is, again, if I put this equal to 1, then your timer will never count, because it will be reset, sorry, it will be reset at every point. Sorry, I had to take water. So it will be reset at every point, right? So that is for this. So the feedback which I want you to see, right, is that V2 is actually heating. Now this V2, this feedback which you're seeing here, are actually made using the name set, right? This is a called feedback here. And if you see, if I go to properties, you will see V2 heating. Actually, I actually made three beds, but it was too lengthy, so I had to make it 2. So V2 and V1, you could see all the messages you are actually seeing on the operator station. So I made with the name set, right? So with this name set, what you do is that you add values to the name set. Like if I go there, you see that if I decide to modify any of these ones, you see that they all have the value. Like V2 has a value of 0, and V1 has a value, V2 heating 0, V2 cooling 1, just like that, and they all have their values. Okay, so going back to here, sorry. Now, and I want it to be, because after all, before it actually came here, remember one of the conditions is that it must be showing, it must be in auto mode, right? So I want to display the value auto mode, just like I did for this feedback. I also use the name set to display the auto and the manual feedback, which you see here, right? The auto and the manual feedback. Okay, so that is for, excuse me, that is for that. Now the next is, if it has to come to this cooling, then it must satisfy this transition, right? The condition of this transition. If I double click and then go to this, what have I said here? I said that the auto manual must be set, it must be in auto, right? It must remain in auto, and then the elapsed time must be greater or equal to the heating, to the time duration, right? To the heating time duration. Now, if you see in this particular one, it has a time duration which I set here as 50, and then it has the elapsed time. So whenever the elapsed time becomes equal to this or greater than this, then I know that my heating is done. So I'm ready to move to the next stage, right? And then what else did I say here? And whether it is running, it must be showing that it is running and not paused, right? If it is paused, then it's going to do something else. But if not, if it is running, then it must satisfy all these conditions. So just completing your heating time alone is not enough. It must actually satisfy every other condition as mentioned in this one. Okay, so for your cooling, just like we did for heating, if we go here, again, these valves are going to, this is your heating timer. Now I'm setting the heating timer. I no longer want the heating timer to be energized. At this point, this is the heating timer reset. I'm resetting the heating timer, right? And that is why you see that at the end of 50 here, it goes back to 0, right? It goes back to 0. If it achieves 50 point something, it's choose to cooling, and then it goes back to 0, because I am resetting the value, I'm resetting the value at this point. So for your cooling timer, I'm energizing it, telling it to start counting, and then I'm making sure that the reset is not true, right? That it's not being reset. And then the feedback, when it comes here, it should be that V2 is actually cooling, and then it should display for me that it's still in what? In the auto mode. Okay, so this is what I want for this step. Now it's going to move to the absorption step only if it completes this step, if these conditions are true. So again, it's going to be in auto, and then your cooling timer, elapsed time must be greater or equal to your time duration for your cooling. And then if that is satisfied, then I'm able to move to the adsorption stage, right? At this adsorption stage, what do I have here? I want to open I want to close the regeneration valves. You could see here 2C and 2D are both closed, and then I'm opening the adsorption valves, right? Opening the adsorption valves. In some systems, actually, they could have some comparison made at the transition level, saying, okay, if the temperature is this and if this is this, because one of the things that do happen is that you don't want hot gas to actually go from your Molesieve to your cryogenic section, right? Because we have what are they called? Cold boxes made up of aluminum, and then you don't want hot gases to actually damage those units. So we may just do extra connections, comparisons, or checks at the transition level to see whether the temperature is okay and within range. All right, so but we don't have that at this point. So I'm opening the adsorption valves for the 2A and the 2B. So this particular one will have to be opened first. So if after regenerating, like this one is being regenerated now, immediately it is not regenerating, it has to open these valves first before, it has to close this one and open this one first before actually closing this ones, right? So it shouldn't go and close this one when it hasn't, it shouldn't go and shouldn't keep this one closed and then try to close this one when it hasn't opened this one, right? Else you're going to have probably a plant trip. Okay, so I'm opening this, and then probably you could see a spike in your flow if this opens together with this one. All right, so the next thing here for me is that these valves are opened, and then your switching time, right? I also have another timer there, your switching timer, and then immediately count. I didn't display that actually, so I don't want that. So after the particular set time, I think it was 10 seconds I used. So it should start counting, and then it should reset the cooling timer, and then make sure that the reset for the heating timer is now 0, because I'm ready to do heating again for the next bed. So, and then it should display for me auto. So now you may be wondering, what are all these? So why are they looking this complex, and how do I have these side bypasses? Now the idea is that while I am in this, you can only reset put this sequence in the manual mode if you are actually in the heating or in the cooling, right? This is actually your heating, this is actually your cooling. So your heating step and your cooling step. So if you are in your heating step and you put this in your manual mode, now this is what is going to happen. Now let's assume that it is not done with heating, or at this point while it is doing these stuffs, you now hit manual. Now this is what is going to happen. It is going to send its value to this particular one, right? To this transition. This transition is going to check. If I open it up, you're going to see that if the auto manual, if I have it in the manual mode, right? If this man has it in the manual mode, remember the only condition on which you're moving from this step to this step is that one of the conditions is that this has to be in automatic mode. So assuming that this is in the manual mode, it's not going to come here. Of course, it didn't satisfy the condition here. So it's going to come here. And when it goes here, it satisfies this condition, and this transition takes it to this manual, to this other step. Now, what do we have in this step? We have in this step that the heating timer, the heating should be de-energized, right? The heating time should be de-energized, and then the reset should be activated, right? So it's going to pretend that no heating has actually been done, right? No heating has actually been done. Probably you may want to change this to, you may want to switch this and add 1 or 2, or even modify this code to suit exactly what you want. But this is just how I want this particular one to operate. So let's say I have, I've already reset this. So this one, the heating timer would go to 0. And then it's going to tell me that it is currently in manual mode. So just like we saw here, if I put this here, I think in this mode, if I take it here, I want to save it. I want to continue without downloading for now. So if I put it in the manual mode, I don't have the button there, I have not provided it. But if I have this button there, you could see that it tells you, right, manual mode, and these values go to 0, right? So even though the heating would have elapse some time, but the putting in manual eliminates all this, and then it's not left for you to actually click any of these, for you to click any of these and open these valves or close these valves yourselves. Okay, so let me go back to my logic. So you see that I was here for this manual. So your manual mode, the condition which we said is that this one will be reset, and then it declares, it declares manual for us. And then the next thing is, after that, there is a transition here. Now after that, there is a transition at this point. Now what is this transition doing? If you trace the line, sorry, some of this looks clumsy, but and I don't have enough room to work with in this one. Probably I should have put them in the sequence, but maybe subsequently in other examples we'll do that. Okay, so you have a transition here to actually check. So on what condition, in case while it is going to remain here, for example, if I put this in manual, see what is going to happen. Let's continue without downloading, and then let me put, okay, it's currently manual now, right? So if I put this in manual, you see that it stays here without actually transiting to any other point. It stays here, and then it reports that it is in the manual condition, it's in the manual mode. So it will remain in this step and not do anything else until the condition at this one is met, at the transition is met. So if I go there and I change this from manual to auto, and then it is ready to leave this step, it has left this step because the condition at this point has been met, right? So when it is met, it actually goes into this same heating. So you could see that your heating should actually start right at this point, knowing that your logic has actually been removed from the manual mode, right? So this is exactly what happened here, and the same thing I did for the cooling, right? So for this cooling, if it sees cooling manual mode while it is cooling, it returns you back, and then waits. If you go back to auto, it returns you to the cooling step, right? This similar thing I have done here also. For the pause, the difference between the pause and the heating is just that in this pause, I have actually used, what I've done here is that instead of resetting, I'm not resetting, so I'm only de-energizing the heating timer and the cooling timer. This is the heat for the heating, and then for the cooling here, I've also de-energized the cooling here, right? And I will just give a message that it is in the pause mode, right? So that is how I did this. If you want this code, I can share with you, and then so you can modify it and get this thing working just the way you want it. But let me say this, if you want any change, probably you're working with a live system, you may need to do one or two modifications to this, because from this code I'm only writing to these addresses or these parameters. For example, like you saw, I wrote to this particular one. Now whether this valve opened in the field or not, I'm only saying, okay, for example, let's say I opened, I just told this valve to open, let's say SV1 XV-1 alpha. So if I tell this valve to open, let's say I monitor this, so this valve currently is being set to close. So if I tell it to close from my program and it doesn't close in the field, how do I know about that? So I wouldn't just go ahead based on the software, right? I should have some feedback to my system, and that is why I've actually made use of the DC block here, right? So that in the DC block you can actually fill in your feedbacks, right? For your feedbacks on the input side to know when this valve has actually closed in the field, which are made by your limit switches. Just like before, if you have any question concerning this, just drop me a message. If not, I will just allow this for a few seconds, and then I'm going to call it a day for this particular example. If you have any question, just like I said before, drop me a message, and then I'll be more than happy to respond to you. And we are almost done with this one, so it will close this now, opens this, and then closes this, opens this. So that will be that for today. Take care of yourself and have a blessed remaining hours of the day. Thank you.